proteins are typically made by microbes in large steel and rather pricey bioreactors. But could insects such as black soldier flies give these tiny little microbial biofactories a run for their money?
So we are FlyBlast, and we've genetically modified the black soldier fly to produce human insulin and other recombinant proteins and growth factors specifically for cultivated meat. And the biggest advantage is that you can farm the black soldier fly at a very large scale and very cheaply, because the whole industry has been scaled to bioconvert side streams into insect protein and lipids. We're just adding a level of technology and profitability because these molecules are very high value.
So compared to, say, microbial fermentation, you don't have the same capex costs?
No, the capex costs are completely different, and also the capex cost is taken care of by the regular insect products. So this is just another revenue stream on top of that.
Yes.
And also what you need to consider is that the molecules we're targeting are specifically animal proteins, right? So it's a lot easier to produce animal molecules in animals rather than in a yeast or in a bacteria, right? So that is a big differentiator. Started out in our feasibility study with looking at, do insects, for example, have insulin-like pathways?
Yes.
And they do.
Yes.
They have molecules that look very much like human or chicken insulin. It's just insect insulin. So asking them to then produce human insulin, it's very close. So for the insect, it's a lot easier than for a bacteria or even a plant, which does not have that pathway.
Isn't it kind of risky if you're focused on cultivated meat as an end market, given that that's going through many challenges right now?
Yeah, sure. So cultivated meat, it is our focus, and it is a market that still needs to happen, and so that contains a risk. But two of my co-founders come from that market, and we believe that we have one of the keys to make it happen. So cultivated meat is going to happen. It will. The question is when.
Yes.
And that's for our investors a very important question, because they need a return within an acceptable time frame. So we are looking at other markets. We chose insulin as the first one because it's obvious what the alternative markets are, right? It's human insulin cheaply and at scale. Hey, the whole diabetics market is out there. But basically our technology platform is a great platform for any biosimilar. Biosimilar being a generic for biopharmaceuticals. We can produce most animal-derived molecules, proteins, but even enzymes on our tech platform.
So people listening to this might be thinking, well, there's already an established market for, human insulin for diabetics. Why not go after that rather than, a risky early stage area like cultivated meat?
It's a very good question. But two of my co-founders, they come from cultivated meat, and they had identified that as the biggest problem for that industry. And it's also an industry where you can have a massive impact in terms of climate. But of course, we have an eye on the human pharmaceutical market, the diabetics market, but we're really going to need a bigger boat to take that on. Because just in terms of regulatory, you're going to need 10 million just to get the paperwork done.
Go through the process,
And then you need to have validated that you have the right molecule, the right purity, etc. We're going to make a couple of steps, and when we get to a certain point where we have those validation points, then we can raise the funds for that biopharmaceutical.
So why black soldier flies versus, say, fruit flies or other insects?
It's all about the upscaling. I've had an insect farming company for 10 years, and we looked at a lot of different insects, and it's about how you scale something in a reliable and in a cheap way. And a lot of the companies ended up with either black soldier fly or mealworm.
Yes.
You can, of course, farm fruit flies. It's very easy. You leave a banana, fruit flies. But to do a lot of them cheaply and reliably, it's very hard. I can imagine 100 kilograms of fruit fly per week. But 10 tons per day is very hard to do. And that is what is happening in black soldier fly. There are factories out there that produce 10 tons of insect biomass per day. So the extraction and purification stage, of course, is the complicated part. Now that we have done the genetic modification, complicated not so much because technically it's complicated, but it just remains a big cost factor because you need to get it to a high level of purity. But that That's the same if you want to extract that molecule from a plant or a bacteria or an insect. So we just need to integrate the regular chromatography with the regular insect downstream processing that has been developed already. So it's that integration, but it does remain a serious cost factor. Basically,
Yes.
Extraction is going to be the determining cost factor for our product
Yes.
sales price.
And after the extraction, can the material that's left over continue in the insect supply chain, or is it contaminated, if you like, with your proteins?
So the other insect products, insect protein, insect lipids, etc., could technically be used in the regular insect value chain.
Yes.
Except that in some geographies, because it is GMO,
Yes.
it will not be accepted as livestock feed, for
Yes.
example.
Yes.
But there are a lot of technical applications
Yeah.
which are outside of the food chain, and there they can use proteins and lipids. For example, lipids, like if they make lubricants, technical lubricants at an industrial scale, it doesn't matter.
No one cares if they're,
whether it's from a GMO source or not. And on the frass, we need to take care, because if we take it out to the field and it does contain GMO traces, so we're going to pyrolyze it into biochar. Now that's 400 degrees for half an hour or more. That completely takes care of that risk. So there's no risk there, and it makes the whole thing climate positive. So we would be doing it anyway, but it does take care of that biosecurity element. Within a year, we have proven that we can genetically modify, and that our breeding strain, we've taken it to now generation 5. So then you have a stable breeding line, and it does express the human insulin at very high yields. It's making it very profitable. That's a lot of validation. Now we need to take the molecule out and supply the samples to our customers, and then work with our customers on which molecules they want next.